All right, so just a refresher on slope. Yes, there is a specific formula, y2 minus y1. I don't get hung up on the numbers. The thing is, you just want to make sure you always go in the same direction. And the most important thing is yum-yums on the picnic table. Okay, so the y is going on top, the x is going on the bottom. That's the most important thing. The order is not that important as long as you're consistent. So like I said, I'm going to do a couple of different examples going different directions. I'm going to start with this one. So I'm going to put a box around it or a star or just underline it or something just to remind myself that that's going to be my first one. It's not saying that I couldn't go the other way. It's just the one I picked. But you have to go in the same direction. You can't go round robin. So I'm going to start with that one, my y, and if it helps you, get in the habit of doing this. If that helps you to label xy, xy, to remind yourself, okay, that 0 minus 1 goes on top. And when I talk about not going round robin, if I do 0 minus 1, I cannot do 2 minus 3. That's a big no-no. I have to do 0 minus 1 and 3 minus 2. What's that going to give me? It's going to give me a negative 1 on the top, a positive 1 on the bottom. You can write it like that, or you can literally just write negative 1. It doesn't matter. Okay? But with slope, we do like to know what the bottom number is, but any whole number is always over 1. Now for number 2, I'm going to go the other direction. So I'm going to underline it. Or you can put an arrow, say I'm going this way. Whatever. Here's my x, here's my y. Here's my x, here's my y. I'm going to start with the 6. 1 because it's the y, and that's the point I chose. 6 minus 1 on top. On the bottom, I start with the negative 3 minus the 8. Okay? And then I just do the math. 6 minus 1 is 5. Negative 3 minus 8 is negative 11. And that's my slope. Now, it doesn't matter where the negative is. If I would have gone the other direction and done 1 minus 6, I would have had negative 5 on top. And negative 8 minus 3, I would have had 11 on the bottom. It doesn't matter because a negative divided by a positive is the same as a positive divided by a negative. They're both negative slopes. It doesn't matter where you put the negative. This one again, you can choose. I'm going to go this way, just because I want to talk about the double negative. So I'm going to start with my 1 minus my 6. And then I'm going to have my 4. Careful, most people have a bad habit of doing that. And that's not what we're doing. It's not 4 minus 7. This is not 7. This is negative 7. So you have to write 4 minus negative 7. When you subtract the negative, then it becomes positive. So 1 minus 6 is negative 5. 7 plus 4 is 11. So it's negative 5 over 11, which actually is the same as number 2. Okay? Exact same, doesn't matter where the negative is. All right? Are any of the lines parallel? If so, which ones? Well, none of them are parallel. Okay? I'm sorry, my bad. I just said the same. I just said it, and I just contradicted myself. 2 and 3 are parallel. I just got done saying it, and I just lost my mind. They have the same exact slope, negative 5/11. It does not matter where the negative is. They're both negative fractions. So moving on. Unit 4, day 8, slopes using equations of lines. So we've talked about this before. Parallel lines have the same slope. In the warm-up, we had negative 5/11 and 5 over negative 11. Same thing. Perpendicular lines have slopes that are blank of each other, opposite. And really, that's just common sense. Why? Well, if I have a line going this way, and I want a line that forms a right angle, it has to go like that. Well, this is a positive slope, because as I told you, my name is going uphill. And this one's a negative slope, because my name is going downhill. Obviously, you can throw your own name on the notes. But two perpendicular lines have to be opposite. One has to be positive, one has to be negative, except in a very special circumstance we'll talk about later. They also have to be reciprocals of one another. And that just means flip. Flip that fraction. So 3 over 5 becomes 5 over 3. 2/3 becomes 3/2. So you've done this plenty in Algebra 1. Slope-intercept form. M is our slope. It's how we move. That's what the M stands for. Not technically, but I like to say that. It's how we move. We move up and over, right or left. The B is my y-intercept. I like to say it's where we begin. B for begin. It's where we put the dot on the graph and then move the slope from there. So looking at these, where's my slope? Right here and right here. Very easy. M is 3 and negative 1/3. Well, they are not the same number, so they can't be parallel. That's a no-no. They are opposite each other, positive and negative. That's a good sign. And 3 over 1 flips to 1 over 3. And remember, we could write that as 3 over 1. We generally don't, but any whole number can be written over 1. Therefore, they are perpendicular, because they have opposite and reciprocal slopes. Okay, let's find our M. Find our M. 2 and 2. Well, they're not opposite, so they can't be perpendicular. And since they're exactly the same, they're parallel. They have the same slope. Examples, pretty much what we just did. So we find our number. Even though it doesn't ask for it, I like to write over here just to practice my identification skills. 4, negative 4. Now, as soon as you see an opposite, people will have the tendency to go, oh, they must be perpendicular. No, they're not. They're both 4. Nothing has flipped. They're the exact same number. One's positive, one's negative. So that means neither. They must be opposite and reciprocal. Right here we have 1/2, and here we have negative 2. So M is 1/2, and M is negative 2, or negative 2 over 1. One is positive, one is negative. 2 over 1 flips to 1 over 2, so we have perpendicular lines. Four and 4, M equals 4, M equals 4. They are the same number. Here we have 3. Here we have negative 2/3. Again, yes, we do have one positive, one negative. We have a 3 in both of them. But 3 over 1 does not flip to 2 over 3. If the first one was 3 over 2, we would have perpendicular lines. But since we do not have a reciprocal, it's neither. Okay, what if we have a graph? Well, let's look at this. How do we find the slope? We just count. We talked about it before. Pick any 2 points. So line A is in red. So that one's first. So first off, write your name on the line. That tells you this is going to be positive. It's a good thing to pre-plan this. Ask yourself, is it positive or negative? Before I even get to the rest of it, look at my name here. It's not drastically going down, but it is going downhill, which means this should be a negative slope. Think about it ahead of time before you start counting. Now, I'm going to pick a dot. Here, I'm going to go up 1, because we always go Y, up and down, 2, 3. So up 3 is positive 3. That's my Y. And then I count right 1. Now, just to show you, what if I wanted to go the other way? Okay. 1, 2, 3. That'd be negative 3. Left 1 is negative 1. And negative divided by negative is still positive. So that is a slope of 3 over 1, or just 3. So I'm going to go, so they got a mess up there, I'm going to go here. 1, 2, 3. That's a positive 3. I'm doing the same line. What am I doing? Brain's not working. Let's try the blue line this time. Okay. By the way, you got to figure out 1. I was just proving my point. Okay, let's try this again. So from the blue dot, I'm going to go down 1. That's a negative number. Then I'm going to go right 1, 2, 3. Well, what do we have? We have a positive slope and a negative slope, just like we predicted. 3 over 1 flips to 1 over 3. We have perpendicular lines. That's it.